These are the video notes for 3A, and the title is Discrete and Continuous Functions. Let's start with a function, and for this case it will be f of n is equal to 3n plus 5. I was going to say 5 plus 3n, that's the same thing. And we can think of this as being discrete or continuous, and it depends on the situation. First, if it were discrete, and let's also draw a line down the middle. In a discrete situation, the change happens all at once. So I'm going to put a box around this. Underline discrete also. An example is, let's say Bella is going trick-or-treating and she already has 5 candies and then receives 3 at each house she goes to. And so if we were to graph this, one, 2, 3, 4. Wait, our x-axis is houses. Our y-axis would be candies. And let's go 5, 10, 15. So we know at the very beginning she has 5 candies. And then after the first house, she gets 3 more. So she would have 8 candies, which is right about here. Then after the second house, she gets 3 more. So she had 8 before, she would have 11. Then after the third house, she had 11. Now she has 14, which is right here. Then after the fourth house, she gets 3 more. So 14 plus 3, she would have 17, which is right around here. So each time she's getting 3 more. And in this case, if it's discrete, we don't connect the dots. So don't connect dots. And the reason why we don't connect the dots is because she doesn't receive any candies in between each house. All of the change happens at the same time. So we don't connect the dots because she doesn't receive candies between houses. Like in between house 1 and house 2, right? It's not like her amount of candies is gradually increasing. It stays at 8, and then not until she gets to the second house, then it jumps to 11. So that's why we don't connect the dots, and it's a discrete function. Or this function right here, 3n plus 5, could be represented with a continuous situation. So continuous. And if a situation is continuous, the change happens continuously or gradually. So the change happens gradually. And a situation for this function that can be continuous is Brian has walked or has traveled 5 miles, then walks 3 miles every hour. And we can draw the same type of graph. Our x-axis will be hours, our y-axis will be miles traveled. Count by fives again. 5, 10, 15. Sorry, it's getting a little crowded over there. And we know after 0 hours he's already at 5, and then after the first hour he travels 3. He's traveled 3 more, so it goes to 8. Then it goes to 11 in hour 2. We're going up by 3 every time. In hour 3, it's 14. And then hour 4 is 17. Now, in this case, though, we are going to connect the dots. So we can say in a continuous situation, you do connect the dots. And the reason why we connect the dots in this situation is because you continue to travel in between hours. So you connect the dots because you travel, he's still traveling in between hours. Unlike the candy situation with Bella, right, she doesn't receive any new candies in between hour 1 and hour 2, so we don't connect that line. But in Brian's situation, between hour 1 and hour 2, he's still walking. So his distance traveled is still going up. So that's why we do connect these lines, because in between hours, he's still increasing his total miles traveled. So that is the difference between discrete and continuous.